the recording. So thank you everyone for joining us today. My name is Timea Biro. I am a senior coordinator at the CSE IT Center for Science in Finland. Before we get started, just a few notes. We're gonna record the session. You should have already heard the announcement and prompted to continue the session. Following this first part of this plenary session, there will be a business and sustainability part to it in the second half with Hillary and Natalie. So please, we kindly ask you to stay on after this meeting. It's going to be in the same meeting room, in the same virtual meeting room. So yeah. Again, thank you for joining us today. As Hillary mentioned in her opening, there are a few experiments that the Research Data Alliance is running with this 18th plenary, and this session is one of them, in the sense that it is organized and has been sort of put forward by a few of the organizational members of RDA, namely EUDAT, so the European Data Infrastructure, the San Diego Supercomputing Center, and the Danish Infrastructure Consortium. But most of all, it's a way of bringing forward an important topic for us. Something that we would like to bring forth to the community and discuss as openly as possible. So it is focused on bringing together the strengths of the data community and the opportunities offered by high performance computing, or vice versa. So the strength of one and the opportunities brought forward by the other. We're going to try to look at a few examples of ongoing work, whether that's around use cases or prototyping HPC services for the data community, or vice versa, the other side of the coin. So developing data services that are optimized for HPC. And we're going to try to discuss in the Q&A after a set of presentation, what are the challenges, technical and social, to combining these two worlds, and what we can do in the future if this is something that we would like to explore further. So without further ado, in the beginning, we're gonna hear from the EUDAT a little bit. Antti Pursula, head of the EUDAT Secretariat, will talk a little bit about the overarching activities related to data and HPC that EUDAT is working on. And afterwards, we're gonna hear from Deborah Testi on a few of the use cases that they have ongoing. So, Antti, if you would like to share your screen, the floor is yours.
Thank you. I'm sharing the screen now, all the slides. Just checking that you can see them.
Yes.
Very good. So thank you for the introduction, Timea, and thanks for RDA organizers for inviting to talk and inviting this session. So my name is Antti Pursula. I'm from the EUDAT Collaborative Data Infrastructure, the head of secretariat there. And yes, my topic today is data management and HPC stronger together. And let me start with the kind of a problem statement. So why do I say that the data management and HPC are stronger together? What do I mean? I would like to start from one angle, and it is the timescales and the duration. So data management and data analysis are different in this respect. In fair data management, the data is stored basically for long term. We want to make the data, research data, accessible and findable and usable for a longer time period, so that it's available for new and novel uses in different types of research. In data analysis, it is essentially a project type of effort. I know this is an oversimplification, but really you have a data analysis project where you aim to do some top-level research with data. But we are looking into cases where someone would like to use the same data over and over again in different type of situations. So the view I have and we in the EUDAT infrastructure have is that supporting the top research, we need both the top-level HPC systems and data infrastructures. Okay. So really, so integrating data and HPC, or making the data services and computing services interoperable, is essential for communities research. And to add here, also one can see that if we talk about really the top-end computing capacity, access is typically limited. So you have their time constraint allocation of time where the most data or computing intensive research and simulation should be done. So you need data on that time scale, but you also need it for probably for pre-processing, post-processing, and so on. So there are different ways where and how data should be available for computing. And really transferring data between these different steps is very important. This figure or this map shows a schematic example, or imaginary example if you want. So what to explain what I mean here. So for example, here you see there a user somewhere in Southeast Europe and who has discovered data, perhaps from an EUDAT service, and wants to do analysis using this data. Possibly there is a pre-processing step somewhere. Then in this case, the user has allocation on a Euro HPC system in the north, does the computation, but when this is done, then additional, let's say, pre-processing steps are needed. And for this reason, the user might move to another national center and doing there the research, and then storing end results, probably publishing something. This again can be in the EUDAT infrastructure. So we see that it's not so simple that there is one machine with data, but really the use case typically is that there are different steps at different systems, and the data needs to be available on all of them. Okay, but I'll take a step back and actually introduce also what is EUDAT to those who are not so familiar with the European landscape. So EUDAT Collaborative Data Infrastructure is a partnership of close to 30 centers or members in Europe, and this makes it one of the few major e-infrastructures for research in Europe. And together these partners are developing, operating and providing data services on different aspects of the research lifecycle. EUDAT is also, as mentioned already before, EUDAT is an organizational member of the RDA. Our vision is that data is shared and preserved across borders and disciplines. And the service portfolio we have in EUDAT is, it as said, responds to different parts of the research data lifecycle. The services are interoperable but still modular, so that for different use cases, different selection or solutions can be made based on these services. There are something that are freely available in the internet, like B2Find for it's a metadata search or discovery service. So one can go there and find research data sets. Then there is B2Share, which is available for anyone to store and publish and describe research data. And for example, B2Drop for kind of a cloud workspace for teams and for individuals. And then there are services that are more under the hood, like B2Handle for providing persistent identifiers, B2Safe really managing the large stored data, doing replications and so on, and B2Access, which is taking care of the user management. So as I said, EUDAT is one of the large infrastructures, e-infrastructures in Europe, focusing on the data services. And as such, we are also part of the European Open Science Cloud, EOSC. European Open Science Cloud, of course, it is the very large initiative from the European Commission to make research services and research data more accessible for researchers across the continent. And EUDAT is heavily involved and contributing to the building of EOSC. And as an example of, let's say, on policy work that we contribute on bringing the researchers and research data and computing together, is a task in the EOSC Future project, which is the flagship project of EOSC. So in this task, we aim to help to align the strategic agendas and technical solutions, and also identified the best ways of enabling the science clusters coming closer to HPC and having HPC resources more accessible for the EOSC users. In this picture, these figures, they are representing the science clusters. So there are large projects here on the, for example, on the areas of social science and humanities, physics, life sciences, environmental sciences, and so on. And Phoenix then is a collaboration of HPC centers working on harmonization and federation of their offering as a European e-infrastructure service. So this is an example of the, let's say, the policy or high-level work that EUDAT is involved in and wants to promote to bring the research data producers and consumers closer to computing and make the computing more accessible. In that, having said that, I think there are also possibilities for co-location. So I already showed the map which showed that there are almost 30 EUDAT centers in Europe, and many of those are national or regional supercomputing centers. So in that case, it is no surprise that some of these same centers are also involved in the really top-end initiatives in Europe for providing supercomputing capacity for research. The Phoenix, which was already mentioned, and the EuroHPC, which will produce three exascale systems. For example, the one in Finland, Lumi, which will be launched probably as the first of them, and being then probably the most effective supercomputer in Europe. So as with this co-location, we see that EUDAT is optimally positioned to have a role here in bringing the data management and supercomputing in Europe closer together and making the whole life cycle or research process more efficient for the researchers. So, as a conclusion, I'm really thinking that interoperable data management and data analysis services have great potential. The data needs to be easily available on different systems, on the top systems, but also on local and national, regional centers, and even laptops. And I also wanted to show to you that EUDAT is working on this topic, both on the policy level and through practical use cases that we will hear soon in this session. So, thank you for your attention. This was the brief introduction to the topic from EUDAT side.
Thank you, Antti. Now we're going to pass the floor to Deborah.
Yeah. Sorry, sharing my screen. Oh, it's not going to presentation mode. Okay, now it is.
You might have to swap the screens.
Yes, I'm trying because the banner is okay. Does it work now?
Yes. Very
okay,
good.
Great. Thank you. I'm Deborah Testi, as mentioned by Timea in the introduction. I'm from the Cineca Supercomputing Center in Italy, but I'm also part of the UDA initiative as user engagement coordinator. So I will present now, after Antti, general overview on UDAT and its relationship with HPC, some more detail on what UDAT is covering in the research data workflow in general, and where we have seen the need of connecting data management services and HPC. In particular, I will go through few use cases just to give a quick overview of the experience we had so far. And then I will give a quick note on what we are working for the future in this context. So if we look at the research data lifecycle generic workflow, like is depicted in this slide, from the data creation, covering all the steps of the data processing and storage and sharing within a team during a project, up to the publication of the data. The data service provided by UDAT, as Antti just presented, are basically covering most of the life cycle, except for exactly the part related to data processing, analysis, and simulation. So far, UDAT has very much been focused on data management services, their storage, and making them fair for further sharing with other stakeholders and researchers. However, we have seen more and more use cases in the UDAT context where the user needed and the community needed to connect the data services that are provided by UDAT with some computational resources. As Antti just mentioned at the start, this connection is being facilitated by the fact that many UDAT members are also HPC centers, and that made this first work on integration much easier. But obviously, this is not enough. So UDAT is working on some improving the technical interoperability of the data services with HPC as part also of the larger collaboration that Antti just mentioned. So what I'm going to show is just few examples, as I said, that are trying to putting together also the boxes that are not covered now by UDAT services with UDAT services. The list of use cases is not meant to be exhaustive, but just to give you a bit of a flavor of where so far used community in UDAT are going. So the first example is the one coming from the CombioMed community, which is a center of excellence that's been funded since already some years by European Commission. They aim to develop computational method for biomedical application. And as you can see from the picture, so in the original use case, the data were processed at the Barcelona Supercomputing Center and then replicated for safety reason into other sites in the Netherlands and UK, and then published. So the use case they are working now is to enlarge the use cases, so to facilitate the simulation of large data set in other center, different HPC center, enlarging this replication network through more sites, so to make the data closer to different centers where exascale or petascale in the future simulation can run. Another example is one from the ICOS research infrastructure, which works on observation system for high quality research, high quality climate change research. In this case, the data are collected from different sensors that are across Europe, and they are transferred to the center in Finland, then processed, and then again replicated to another center in Jülich. But also in this case, the aim is to provide a larger environment where storing data and staging data for analysis to compute platform, and also investigating other possibility to publish the data besides their own specific community portal. Another example is from the marine data infrastructure, SeaDataNet. In this case, data are coming from our large and diverse set of data deriving from sea and ocean observation. And also in this case, we have a distributed network of sites across five locations that is being designed to improve the accessibility of the data close to the computational facility than to perform all the needed data analysis. So this is a larger network of centers involved in the process. As a last example, one a little bit different is one from the Earth System Modeling Network that is investigating climate and Earth modeling. In this case, the aim was not to bring data towards computing, but the other way around. So they work in integrating their computational environment based on Jupyter notebooks and Ophidia, connecting this to data services, both for the incoming data and for storing the outcome of the analysis, so to facilitate the processing of the data. So in this case, it's not the data that is moved to the computing side, but the Jupyter notebooks which are moved where basically the data are located. So as I said, these were just few examples just to give a quick feeling of what communities are doing in this context of data in the HPC. But as I mentioned, we as UDAT think that we need to work also on the technical side of our data services and improve the integration, in particular with the storage resources that are in the HPC facility and are close to the computation. For this, we have included into a recently funded EU project called DICE, which sees a strong participation of UDAT members, exactly an activity to better connect data services and compute. And this activity is in particular focusing on improving three of the UDAT services. One is the B2Drop, so to use the service to maintain the recipe for analysis, so allowing small data transfer towards the HPC system. Then the majority of the work is going around the B2Safe service, which would allow to safely store the results of the simulation and analysis. For this, we are integrating to the service a specific storage that is typical of an HPC center, connecting the service to our authentication and authorization mechanism, and also allowing to better move data to and from the specific service. As a last step, B2Share is the UDA tool that you use to publish data, and we think we should make it easier for user after the simulation has been performed to publish the data without having to re-upload the data into yet another service. So integration is ongoing between B2Safe, where the data after the simulation will be stored, and the publishing tool so that data will not need to be moved. However, the main challenge we have been facing so far is related obviously to the different authentication and authorization mechanisms that are in place between data services and computing facility. And on this, first, let's say, proof of concept is under analysis to try to federate the UDAT authentication mechanism that is called B2Access with the Phoenix infrastructure authentication and authorization mechanism. When this will be, if this will work, this can be, say, the first step towards more integration, also towards the new HPC system and further big HPC facilities. That was everything from my side.
Thank you very much, Laura. That's great. I see that there are already questions in the chat. We're going to try to cover them later on. Now I'll pass the floor to Melissa, and let me see if I can share the screen to support you with the slides. Let me know if it's the right screen.
You need to switch, please.
Okay, there you go.
Super. Thank you very much. And thanks to Mia. Thanks, everyone. It's a great opportunity. What a wonderful session. So good morning, good afternoon, good evening. I'm going to do a very cursory run through the ecosystem of advanced computing in the US, look at some resources. You'll see threads throughout that really start to link human resource efforts, the human infrastructure that we're needing to build up to really help support our growth in HPC, both regionally and globally. Next slide, please. Thank you. So this will be a very cursory snapshot. And of course, it is my own view. There are folks on the call today who might say, hey, you left out this or that, or have a different perspective. But this is a very high level snapshot. And I'll introduce some federal initiatives that target research data management and FAIR for HPC and advanced computing, and some projects that sort of sit at the intersection, just to give a flavor of the activities happening and where there are real opportunities, I think, going forward for more of these sorts of activities. Next slide, please. So I start with the National Science Foundation funded EXCEED program, which has been running now for more than a decade. There'll be a new program to move this forward and help really build out services. But EXCEED now is managing and provisioning services out of these very large advanced computers and supercomputers across the US. The EXCEED is a network, an ecosystem, if you will, of a broad set of service providers, a federation that primarily consists of autonomous entities and coordinate with each other to provide services in varying degrees of interoperability and integration. These services are provided at different levels. What that means essentially is that some organization has signed up to integrate to meeting some level of requirements. Just as an example, I am part of the Open Storage Network, which is an infrastructure providing petascale level storage for active data across the US. Active data means projects that are ongoing for the next 3 to 5 years, or community level community data resources that are made available very broadly across the US. The OSN is situated near HPC centers, and we're a level 2 service provider, meaning we interoperate and use the services for allocation applications and provisioning through EXCEED. Next slide, please. So one of these new advanced computing resources is actually based at the San Diego Supercomputer Center. The Voyager Machine is our newest high performance resource and tuned for conducting artificial intelligence research across a wide swath of science and engineering domains. This innovative system will be first of its kind available in the NSF portfolio. Its architecture is uniquely optimized for deep learning, operations, and AI workloads. In our division at SDSC, where I work with Christine Kirkpatrick, we have active projects on machine learning and reproducibility, and these projects will inform the provisioning of research data services across the SDSC. Next slide, please. So I want to introduce the Cloud Bank service. Some of you may have heard of this, but this is a project also funded by the National Science Foundation, the University of California, San Diego, both the Supercomputer Center and the Information Tech Services Division on campus, University of Washington's eScience Institute, and University of California, Berkeley's Division of Data Science have developed and operate Cloud Bank, which is a cloud access entity that helps the computer science community access and use public clouds, that is the commercial cloud, for research and education by delivering a set of managed services designed to simplify access to these services. And these include AWS, Google, and Microsoft's Azure. Information, education, and training resources are available to anyone in the research community, but allocation of cloud services is provided to projects that belong to the NSF programs and specify the use of Cloud Bank in the NSF solicitation. So essentially, people put in proposals to NSF and they request Cloud Bank services, part of that proposal. And if the project is awarded, then they get access to the Cloud Bank services. Next slide, please. I shift now to the DOE National Labs, and I bring this up because there is a very large project underway there, moving toward exascale computing, called the Exascale project. This will scale machines and provide exponential increase in memory, storage, and compute power in pursuit of the DOE and national mission for science discovery, national security, and national energy services. This will be a milestone in computing because today, while we're working at petascale and the systems are quite powerful, the computing at exascale will be transformative because of the degree of problem-solving capability it will enable. This will work, of course, for precision medicine, new kinds of discoveries and methods in precision med and materials discovery, Earth systems, astrophysics, and more. The Office of Science, there's also deep consideration about emergent needs and requirements to make the most of data. Next slide, please. And the Advanced Scientific Computing and Research Division, which is part of the Office of Science, has a program that they ran last year to advance fair data for artificial intelligence for science. As part of the program, about $8.5 million were awarded for several projects under this program, this opportunity called Fair Data and Models for Artificial Intelligence and Machine Learning. And here's a list of the awards that were made. Some you can see are collaborative. They're the same title and made to different institutions. If they're the same title, those are collaborative projects. And just as an example, next slide, please, of one of these projects is the FAIR for HEP, High Energy Physics. Thanks very much to Dan Katz from NCSA at University of Illinois for sharing his slide on this new funded project. Dan presented last week during the RDA BOF, Steps Toward Defining FAIR Principles for Machine Learning. And if you're interested in learning more about this project, it was recorded, and also the session is being repeated later today. But this project, as you can see, is really focused on thinking about applying FAIR principles to provide rigorous data sets for AI and innovative computing. And so they are working, it's a collaborative project across many institutions, and they're really working to build out new both practices and tools and resources for providing AI-ready data sets and models. Next slide, please. I want to just highlight quickly, I know I'm getting close on time here, another project that was rolled out last year during COVID, and that is the High Performance Computing Consortium for COVID-19. It's a unique public-private partnership led by the White House Office of Science and Technology Policy, US Department of Energy, and IBM. It spans industry, DOE labs, federal agencies, and some international governmental agencies, and also national labs from international partners. They award compute time for research projects intended to provide benefits to COVID-19 response in the near term, so 6-month impact of these projects. So I won't spend any more time here, but I wanted to point this out. Next slide, please. Next slide, please. Thank you. And a companion, a sort of companion, but not necessarily done at the same time, was a project funded by the National Science Foundation called the COVID Information Commons. This is a consortium effort to bring together project-level information on awards made by NSF about on COVID-19. And so there are search mechanisms now made available to find all the research funded under the a couple of different programs that funded COVID-19 projects to help make those resources better available to the public. Next slide, please. Thank you. So I'm almost wrapped up here. I want to take a moment to talk briefly about human infrastructure. In the US, as in elsewhere, there are programs designed to train staff in HPC and cyber infrastructure who serve as scientific software developers and architects for connecting data and cyber infrastructure services. While liaison and project Sherpa kinds of roles are almost always part of this work, new professional roles are emerging that bring more focus to these activities and to help bridge research IT, cyber infrastructure, and data expertise. Campus champions, for example, are a group of several hundred people situated across 300 plus US colleges, universities, and other research-focused institutions. And they help researchers at their use of research computing, including HPC. These folks also peer mentor each other for continuous training. There's an annual virtual residency to help train new people coming on board, and other organizations you can see as well. CARC is particularly interesting because it includes people from many different staff roles across research organizations in the US and have both compute-facing, research-facing, and data-facing activities and training. So really good ways to build community, share information and expertise, and grow the human infrastructure resources, the staffing we need, professionalization that we need of these staff roles across the HPC and advanced compute environments. Last slide, please. So I want to just mention this kind of a new partnership specifically organized around data. So this is a collaboration between Lawrence Livermore National Laboratory, which is one of the Department of Energy National Labs, their Data Science Institute, the University of California, San Diego Library and their data science librarian, and the Halegiolu Data Science Institute at UC San Diego, and the students that work there and are part of the projects there. They have worked together to develop a number of publicly available data sets now available for AI and machine learning and other uses. There are 6 data sets there. They're continuing to work on these, but they have curated and made open these new big data sets for all sorts of applications. And I think that this is a kind of an opportunity where taking data being produced in different research organizations and being able to put these out and host them along with tools and access to expert resources to help support the use of these in education and training is quite important and a new a new kind of role. Okay, that's the last slide. Thank you very much. Appreciate your time.
Thank you as well very much, Melissa. I'm going to pass the floor to our colleagues at DAIC, so the Danish e-infrastructure consortium. So we have Eske Christiansen, who's head of HPC, and Anders Conrad, who will speak to us about the work that DAIC is doing in the field. Thank you.
Yeah, and thank you for the invitation. My name is Eske, and I'm here with my colleague Anders, trying to describe what we do at DAIC. Before we really start, we have to explain what DAIC is. In Denmark, we did a total reboot of the HPC and the data management landscape at the national level, with a new agreement between the 8 universities and the ministry to have a new collaboration on a way forward for the national part of HPC and data management. DAIC was also transferred into a knowledge broker situation. And as you can see, the idyllic picture in the left, and what we have is the reality is in the middle picture, where we have to be a knowledge broker between 8 different universities with different level of knowledge. In 2019, we did a lot of work in looking into what's the need for HPC, both and data management at the national level. And we started with doing the HPC, as that was probably the most the easy part. We ended up with identify 5 different types of HPC systems that we want to provide for our users. We have the interactive HPC, it's a cloud-based HPC system where users have an easy access to. And the other 4 HPC system is more traditional queue-based system. And we also see that Lumi as an integral part of the Danish national HPC landscape. As you can see, we have also written data management and GDPR compliance privacy regulation in this nice pictures. But the reality is that we started without having any data management and GDPR regulation to have an easy start. Some of the success and some of the challenge we have seen with the setup, the success is that we have many new users in HPC. For the last year, we have been running this, we have seen over 1,500 new users in HPC, and that's mostly done, and mostly in the cloud-based HPC, in the interactive HPC. We have also been doing a lot of awareness communication in HPC and data management on a national level. And we have also made a new support structure for the universities, so that researchers will get support locally and not have to try to get support at a centralized place. Some of the challenges also the new communication flow, and GDPR have turned out to be a major challenge to get this right. And also we have no data management yet, and Anders will talk a bit about that. Anders?
Okay, I'll take over. As Eske said, the HPC and data management has to some extent been moving on as a parallel tracks, and also we identified recently at a seminar that it to some extent that which was interesting, the flows of competence are quite differently in these 2 worlds. And indeed, in the data management, we have been doing for some years, but mostly focused on what you could call the more soft areas. We have been much involved in FAIR, in training materials. For instance, we have been running a data management planning tool for some years. We're supporting metadata for machines workshops and tooling and stuff like that. But now we are moving into the real infrastructure business at a national level. Our board has an open call for universities to provide currently distributed storage infrastructure, which is mainly really seen as infrastructure as a service solution, where we think that this will be nationally available to researchers, and we envision there'll be a number of different data centers with, to some extent, different characteristics, supporting different use cases, and indeed we think about the life cycle perspective that not all data needs to be curated and published, but that a lot of data are intermediate and have to be accessible for computation. So our board is very focused that these centers must be easily integrated with the HPC centers that Eske just told about. Then at the publication side, there will be a data repository which should build on the storage and that would be for the published data, which have to be curated for a number of years. And finally, not yet part of the call, but on the budget is that verification tools should be provided as a national resource, because we just published a national fair data management strategy, and we really need to support that both with tools, with methods for verification, and with the competences and competence development, which will be actually a huge endeavor. So you can change to the next slide, please. So with that will be the sort of data track running on its own, but really from next year on, we are starting to work more deliberately on how do we integrate all these components into a real coherent infrastructure, and not just a Danish national infrastructure, but it should be an integral part of the global research infrastructure, including stuff what we've already seen and heard about EOSC. So the three bottom parts are the three pillars of DIKE, which is HPC, our research network, since we are the Danish NREN, and the data infrastructure that I just described. So we have to sort of formalize more what the interface points are between these components, and that's to some extent the middle box, which are what you could say all the enabling infrastructure bits and pieces. One very important one is going to be about authorization, AAI. I included the third A because accounting is important in this national system. Which protocols will be used for which purposes, and to bridge between components, and also indeed security, as trust is a major part in this landscape, as not the least because it's between, as Eske showed, the 8 different universities. They need to have trust in each other when they deposit data, for instance, from one university to an infrastructure that's being operated at a different university, or for computation at a different HPC center. So all these things we need to take care of into a kind of coherent architecture, which again is very much guided by, for instance, what's going on in the EOSC development. So we look into which architecture frameworks are already in place or are being shaped by the different working groups and task forces in EOSC. So I think throughout next year, we'll have a strong focus on how we build it all together. So I think that concludes our little presentation. Thank you very much.
Thank you as well. So if everyone else would like to turn on their cameras. So we've heard a lot of great examples of ongoing work, and everyone seems to have identified a few of the more technical issues, but there seems to be also great interest around the use cases. Thank you, Antti, for answering some of the questions that have come in through the chat. I see that there's one from Jonathan that hasn't been answered, so I'll start with that. So from the cited examples, what is the order of magnitude of the data that is involved for computing? And possibly maybe from that on, maybe we can move also to a point that, Melissa, you have raised around scalability. But Deborah, I don't know, in the use cases that you have.
Yeah, the use cases I presented are normally dealing, I mean, every use case has its own size, but let's say we are in the order of a few hundred of terabytes normally of data being replicated and shared. Obviously, the aim is to allow this to scale up to larger data set if needed in the future. So, but so far the size of the use cases I mentioned is around that amount. So not really huge project, but not so small either. So I don't know if Antti would like to add anything on that.
Well, you certainly know better the volume there is in the use cases, but of course I can take the opportunity, and there were questions about especially from Francois to the network capacity. So of course there can be cases as mentioned for some kind of a near real-time computation, which is a different case. My understanding is that we are so far working mostly with cases where we kind of stage the data close to the computing, basically in advance of the actual data processing step. So in that sense, I see that the network capacity is not then limiting the performance. And maybe to me this is quite a natural workflow, in fact, to use the typically very large storage locally to supercomputing systems, which is optimized for the, I mean, input, output, and speed and so on, to bring the data from external repositories close by, have it there as long as it's needed, week, month, year, but then after this project is ending, then move with the new data basically back to another repository or publish the data sets.
Thank you very much, Antti and Deborah. Melissa, would you like to add anything from the sort of US side?
Sure, I would. So the Open Storage Network is a good example of, so it's a national substrate. We are working on allowing, so we have buckets, allocations that have hundreds or thousands of files, and also sit in the hundreds of terabytes range. So the sort of range for OSN is tens to hundreds of terabytes. And we utilize the Internet 2 network to move those resources around the country. But the point, or a couple of points were raised, and that is that there are still some disjoints between the components or the parts of the ecosystem. So we have data service tools, for example, that are able to publish for publishing and moving data, but those tend to be in the gigabyte, in the tens to hundreds of gigabyte range. It is difficult still to find tools and resources to move and publish data that are larger than that. And of course, in the academic world, while the Department of Energy is working toward exascale, in the academic world, we're still really the bulk of the projects producing data and putting data in repos are in the gigabyte range. And so, we've got some work to do to sort of cut across the infrastructure with some new tools and be able to support some of the data movement, particularly across the data lifecycle. So off-ramping data out of one service to another, we still haven't quite solved that problem yet.
Thank you very much. Anders, would you like to add anything to that?
Not much. This is where I'm come a little short of my knowledge of the real world problems. I haven't heard of any unsolved, and our board thinks this is a matter of expanding the research network sufficiently. That's their strong belief, and so far I've heard no complaints.
Okay, thank you very much. Well, that's a set of problems that others are addressing. So when you're going to be working closely on this, hopefully there will be a good exchange of information and best practices on this. Françoise, I think you had another question about related to the cases where computation is done near real time with massive data acquisition, or was that in relation to your previous exchange regarding?
It is a flow of the same question. When there is an answer, I think about it and I ask another question. So it's in the flow, and I think Antti has answered. I think that it would be really interesting to explore cases in which there is a need for near real time, because in some cases it can be linked to urgent situations. And this is where you need to answer before it happens.
Okay, thank you very much. Are there, so this is a question to the panel. Are there any areas that you think the RDA can particularly contribute? I mean, I would understand that all of them are very delicate topics, but anything that you can pinpoint in terms of a challenge that can come out of any of the working groups.
Hello, here is Jonathan Schaeffer. I'm a bit shy and new here to the attendees. Maybe I'm naive here, but data repositories sit often next to a computing facility, but sometimes not. And scientists need sometimes to move the data from the data repository to a remote computing facility. So usually the request systems are synchronous. So you make your request, you get the data. And in this use case, the synchronous doesn't help a lot, and it's somewhat limiting the data amount you can move. So my question is, how are asynchronous protocols managing this? Do they exist? I don't know about them. And maybe RDA knows something about standardizing the data movement between data repositories and computing facilities.
Would anyone like to take on any of the two questions? I think you had.
Yeah, I would just jump in from my point of view. As you could see, we are very infrastructure focused in the moment, because to some extent our work is, you could almost say, budget driven, that now there's money that has to be spent to build something. So I think one thing RDA could probably provide, maybe a little bit along the line of what Jonathan just said, is just kind of clarify some distinctly different use cases that could guide us into how we build this infrastructure to best serve the research community.
To everyone out there, I think that's doable. So
Yeah, I basically had the same feeling that Anders said, that this could be to refine or span or assess use cases or collect use cases, I think is the right word. And I see kind of a general agreement here that the workflows of how do you in practice bring the data repository and computing together are of interest. So I think some kind of mapping of the area would be needed first, and that is maybe something where RDA could help or be the forum.
Okay. Yeah, thank you very much. And with that idea and formal request, we're gonna close the session. And I thank you very much for the very informative presentations, and hopefully this can be taken forward. As you have pointed out, there's a lot of work that needs to be done, and the RDA can play an important part in that. Thank you very much, Hilary and Natalie. I think I'll pass the floor on to your business and sustainability session. Please, everyone,